All right, so we've started recording here. Again, sorry for the no live stream today. Just like this morning, we had a terrible internet over here in Avery Hall. So consequently, we're going to have to record this one. But it'll be the exact same thing. We're going to finish up with object-oriented programming today. And then get into, on Thursday, we're going to get into SQL, the next module. So today, what we're going to finish up with today is best practices and pitfalls for using object-oriented programming. So best practices and pitfalls in OOP. Right? And this is just this is not exhaustive list by any means. It's just and some of this stuff we've gone over before. It's just that I want to make sure that I point these out specifically. And we're also going to go over what are called the solid principles. So like we separated everything out into the four pillars of object-oriented programming. I'm going to talk about each one individually so that you can, some of these things apply to multiple categories, but encapsulation, the best practices, again, are, this is something in the solid principles, but it's, we'll talk about that later. You generally want single responsibility. Each class should only be responsible for one thing, right? You don't want a class to be responsible for two things or three things or everything. That leads to what's called the God class anti-pattern. Avoid the God class anti-pattern. So a God class is a class that knows everything, sees everything, does everything. You don't want that because just like in C, or another non-object-oriented programming language, you don't want a function to do everything. You don't want all your code in one spot. You don't want to put all your eggs in one basket. You want to separate them out into different concerns. And whereas in a programming language like C, your unit of code is a function, a single function, in an object-oriented programming language, your unit of code is a class. And so it makes sense that one unit should be responsible for one thing. An address class should be responsible for address things. A person class should be responsible for person things. And you want to keep those all separate. If you don't, then you have the God class anti-pattern. And we call these things anti-patterns because of, well, what are patterns? Patterns are best practices, best behavior. They're software design patterns. They're good habits to get into. So what's a good what's the opposite of a good habit? It's a bad habit. What's the opposite of a pattern? It's an anti-pattern. It's a bad behavior that is nevertheless common that you see all over the place. And so one anti-pattern in object-oriented programming languages is the God class anti-pattern. In general, you'll also want to keep things private. Keep member variables private unless, and I'm going to have to cut and paste here, there is a very good reason to do so. There, I trademarked it. I finally found the trademark. Unless there is a very good reason to do otherwise, right? Yes, you sometimes want the ability to change an object's state. In that case, there are much better patterns, best behaviors, good habits to get into to follow, rather than using setters, right? And in this respect, the final keyword is your friend, right? It makes a variable into a constant. Once set, it can never be changed. Doing so is a compilation error. Right? And I don't remember if we did it or not in this section, but of course you can go ahead and have, say, here's an address class. Now I don't have any setters here, so this is technically immutable. If you wanted to make this ironclad immutable, you could make every single one of these private variables into a final variable, right? And once you've done that, then trying to reset it, there we go. Trying to reset it will be a compilation error. This.street is equal to foo, right? That's not going to compile anymore. Because I labeled this as final, once I set it on here on line 12, I cannot reset it here on line 16 or ever again in my entire program. So not only can you make your objects immutable by not allowing setters, you can make that ironclad by using the final keyword here. Right? Or if you do absolutely need the ability to make changes, use a different pattern. Use patterns like copy constructors. Right? And I think that we've talked about copy constructors before. If not, go ahead and check have we not? All right. The isotope. The isotope definitely had a copy constructor on it. A copy constructor would look something like this. If you want a deep copy of an address, you would have another constructor here, public address, that took another address, and I'll call it that for now. That, of course, you shouldn't do that. I'd call this A in general. But just to get the difference between this and that, what you can do is this dot address, say street, is equal to that dot street. Right? And this makes a deep copy constructor so that if you ever need another a clone, basically, of this thing, then, of course, there's more work to do here. I would have to do the rest of this. That's the idea. That I want a copy of this. Okay, I'll put this into a constructor, and it makes and it just copies over all the state of this one object. It doesn't have to be a pure copy constructor. You could, for example, take a different zip code, string zip, right? That will copy over every single aspect of this except for the zip code, in which case it says this.zip is equal to zip. Instead of that address zip code, we'll go ahead and use this other zip code over here. One use case for your project would be if you've got a gift card. Gift cards have no amounts unless they appear on a sale. So you can take a gift card and put it on sale A and set it to be $50. Now I've got a gift card and I need to put it on sale B. Call your copy constructor, set it equal to $100 so that you can put it on that other sale, right? And that way you get a deep copy, but they have different aspects. This one's $50, this one's $100, okay? But that's a copy constructor is a much better alternative than having a mutable object, because it won't even work on your project that way, right? If you've got here's a typical mistake and pitfall that people fall into. Here's my gift card object. Put it on sale A, set it to $50. It's the same thing, not deep copy. Put it on sale B, set it to $100. Guess what happens to the original? Now it's $100 as well. So you want deep copies of these things usually. Finally, don't break encapsulation by locating behavior outside of a class. The example that we did was depositing money into your bank account. If you have this function over here that takes a bank account and the amount to be deposited, and then it does all the logic for you by getting the balance out, adding this to the balance, and then resetting the balance, that's locating it outside the class. Simply just put that functionality inside the class where it belongs. Right? For abstraction, the biggest pitfall that you have are called leaky abstractions. And I think we briefly talked about this when we did the person class. And we, in some sense, the first version of that, we required somebody to build this list of emails and then give it at construction time. That's a leaky abstraction because we were advertising to the world, hey, the way that we model emails is through a list of strings. We shouldn't have to have that, right? Poor object design means that the outside world requires knowledge about the internal workings of it in order to use it. Here's a really good credit to my wife here. She came up with, I described to her what a leaky abstraction was, and I said, give me a real world object, because I couldn't think of a real world example because, of course, we're in our computer science world over here, and we're like, give me an example. And her example was automatic versus manual transmission, right? So anybody drive stick? All right, whoa, wow, okay. Do you prefer to drive stick? Okay, all right. So that's why I was, when she said this, that's a perfect example, except lots of people like driving stick, right? And so I'm going to come at this from I've only had one stick shift in my life, and it was a 93 Ford Festiva. And believe me, that's not a car that oh wow, stick shifts, right? You like stick shifts because of muscle cars or whatever, and that was the very opposite of a muscle car. But anyway, if you've never done it before, how do you do stick shift? Well, you have to start in first. You have to push in the clutch. You have to go into first. Then you have to let the clutch go while you're doing the gas, right? Then you have to shift up into second gear, third gear, fourth gear as you're picking up speed. If you ever need to stop, you need to go into neutral and hit the brakes. Or if you want to it's really bad on your clutch, but if you want to, you can downshift and then have that brake for you. You don't want to do that. Brake pads are much cheaper than a new clutch or a new transmission. But anyway, there's a lot of thought that goes into that. And you like if you like driving and you have a muscle car, then you like doing that stuff. But the vast majority of people don't like doing that stuff. The manual transmission is a leaky abstraction because it forces you to know how a transmission works in order to use it. Right? Eventually, it becomes second nature, but it's still a lot of work to use it. Whereas an automatic transmission, how does it work? Go, stop, go, stop. It takes care of all the details for you, right? So a manual transmission is a leaky abstraction because it's not abstracting away any of the work. All the details, you still have to worry about it. My example that I came up with of a real world one would be a washing machine. You ever go up to a how do you work a washing machine? There's just a wash button, right? And it takes care of the details for you. Imagine a washing machine that had a leaky abstraction. You go up to it and there's a fill button, fills with water. Once it's done, you have to come back to it and hit the spin button, right? And that starts spinning and actually washing the clothes. Then once it's done, you hit the empty button that drains the water out. Then you have to go into a rinse cycle, so that you come back to it again, and you have to hit the fill button, and by this point you're here. Then you hit the spin button so that it rinses it out, and then you hit the empty button because you get rid of the water, and then you go spin once more in order to get rid of the excess water. Has anybody used a washing machine like that where you had 7 buttons that you had to push in sequence? Nope, that would be a leaky abstraction. The good abstraction is you just simply hit the wash button and you set it and forget it, right? But there are examples directly in code of this. For example, strings in C versus strings in Java. Which one's far easier to use? Java. Why? You just concatenate. No memory management. You don't have to worry about null terminating characters. You don't have to worry about, does this particular function put the null terminating character in there for me? Under what conditions might it do it, et cetera, et cetera, et cetera. C strings are leaky abstractions because you are forced to do all the details yourself. Java strings are an abstraction of that. How are they actually represented under the hood inside that class? Who cares, right? The real answer is it's a character array, but it's not null terminated. Right? You can rip open the class and look at it all you want, but most of us don't care. We want to keep the class closed, encapsulated, and we want to have the benefit of abstracting it and only looking at it from the outside. Right? We don't want to have to worry about those low-level details. Another good example is the local date. Right? Local date was not leaky. We had to rip it open to find out that it represented a date with 3 integers, month, day, and year. We just used it. Right? It was not leaky. It did not force us to know what the representation was. Was it a string, an ISO 8601 string? No. Was it 3 numbers? Was it 1 number from some epoch? We didn't have to worry about that ever. Right? It's not a leaky abstraction. One other example that I did this morning, and that we'll come back to later on when we look at, or that I mentioned this morning, we'll come back to this when we look at list-based data structures, is the list.add method. Now, this is not the real method in Java, but think about it like this, right? It just that first version where you have an element x and you want to add it to at index I, it just works, right? You just, okay, here's x, here's I, you take care of the details, Mr. List, right? I should start calling these things Misters and Misses or whatever, right? Otherwise, there's no, this keyword is the only way that we can refer to them, right? Leaky would require you to produce some details. For example, how does this actually work? Well, the list shifts everything down to make room for that element, and then it puts that element in there. What if we had to do that in sequence? What if we had to shift everything down at index I to make room, and then we had to call this other method that allowed us then to put it in that gap? Sorry, there we go. Right. That's not convenient at all. That's a leaky abstraction because it's leaked information about how this actually works. Inserting something at a particular index requires shifting things down and then putting it in there. I don't want to have to worry about those details. And finally, this, the example that we'll come back to later on is an array-based list versus a linked list. If you require the details of which one it is, then you're doing something wrong, right? That's basically a leaky abstraction. I need to open it up to find out what's inside. That's a huge red flag that you're doing something wrong, right? And we'll come back to that later on because it does have severe implications. It's not just a design thing. The difference between these two and the algorithms that you use on these two can mean the difference between a few nanoseconds of execution time versus several weeks of execution time. Yeah?
So would the array-based list be preferable then?
Yeah, there you go.
Data you want like the data, like what order the array list it's in, or?
Yep, exactly. So an array-based list means that you can exploit, say, binary search. A linked list, where you don't have random access, means that you can't, right? And so leaking that abstraction out may be a bad idea. It may be a good idea if you're about to run this algorithm on this data structure, and it's inefficient if it's one representation, but it's efficient if it's a different representation. You may want to check that. And that's where interfaces come in. If you remember, let me go ahead and bring it up. iCloud. It's on iCloud here. Here's a collection hierarchy, right? So I'll draw your attention up to this interface right here, random access. An array list has it, but a linked list doesn't, right? So we can leak out some information here about our list in order for you to make an informed decision on which algorithm to use. I'll check, does this have random access? If so, oh, I'm good to go on binary search. If not, don't use binary search because it will not be efficient. Just use linear search. Yeah? Or you'd have to use something else, yeah, entirely. All right? With inheritance, there are a whole bunch of pitfalls that you can get into. The first one is not an issue necessarily with Java, or it wasn't at first, but it's multiple inheritance. And at this point, I'm going to try to use my new toy. Right, there we go. And good notes. There we go. So multiple inheritance. Not that you would want to do it, but here is a potential inheritance, right? We'll have an animal, right? And a dog and a cat. And I think we can all agree that a dog is an animal and that a cat is an animal. So maybe we have an inheritance hierarchy that looks something like this, okay? Now in a language like C++, where you can do multiple inheritance, not necessarily that you'd want to do it, but you could inherit from both cat and dog at the same time. What would the result be? An amalgamation. This morning they said an abomination, or cat dog. Okay. Right? There's a cartoon cat dog, and there's a cat on one end and a dog on the other end. Right? And I'll leave the rest of that to your imagination. So what's the problem here? Well, all animals speak. A dog says bark, and a cat says meow. Right? Bark. Rough, whatever. Right? If I inherit from both a dog and a cat, right? I inherit from both the dog and the cat, then what does the cat dog say? That's what I said in the morning. I shouldn't be, right? So, question mark, right? This is known as the diamond problem. Why is it the diamond problem? And for this, I think I can draw a diamond, right? That's as close of an approximation to a diamond that I can get. Maybe if I, let's see, everybody loves new toys, right? So let's try this. You got to get it exact in this. Okay, it's still not exact. But there's the diamond problem. When you have multiple inheritance, which one are you inheriting it from? Now, in a programming language like C, you have to be explicit. If I were to create a cat dog, then I would just have to say that I get my speak method from the dog, and therefore I say bark. Or I'd have to explicitly say that I get it from the cat, or I do something completely different. No matter what, though, it's completely counterintuitive because, well, one, this shouldn't really exist, right? And if you ever have a design like this, it's a huge red flag that you should probably be rethinking what you're doing, and that there's probably a better way of doing it. But not only that, even if you have good cause to do something like this, it forces somebody to continually go back to the documentation and which one did I inherit it from again, or is it completely something different, completely different, right? It leads to complexity, and complexity means that you always have to have cognitive load, and cognitive load leads to mistakes, right? Keep things simple, stupid, right? KISS, K-I-S-S, keep it simple, stupid, or don't over-engineer things, right? Because the more complex something is, the more failure points it has at whatever your failure points might be. So be careful of the diamond problem, right? And again, the example is an animal, a cat, a dog. There's an ambiguity there. Which one do you actually inherit from? Now, I will say that this is not possible in Java. You cannot extend more than one class. Unfortunately, in Java, they did start allowing multiple interfaces in, you can do multiple interfaces. You've been able to do that from the beginning. But Java 8, unfortunately, introduced this concept of default behavior. Remember that these are pure abstractions up here. Interfaces were supposed to be pure abstractions. There are no implementations up here in the green land at all, right? Until Java 8. Java 8 introduced the notion of a default behavior, where you can define an interface to have actual implementation. This leads directly to the diamond problem. If you've got something that implements an add method in interface A and another add method in interface B, and there's default behavior on both of those, and you implement both of those interfaces, now you're back at square one and you have the diamond problem again. Unfortunately, I think it was a mistake, but you should know that you can do this to an extent in Java 8, but just because you can do something doesn't mean you should do something. And unfortunately, I think that was a mistake that they introduced into the language. Traditionally, Java has only been a single inheritance hierarchy, but you cannot inherit from two classes. Right? So, yeah.
Could you put that under like have a little message that says don't do that then?
Oh, okay.
Otherwise, I think it's best practice.
Yeah, generally don't. Generally, you want to avoid this. Right? There are only some I think that I think that they introduced this because of iterators, and basically anytime you did an iterator pattern in Java, the interface had these three methods that you had to do: next, has next, and then remove. And nobody ever wanted to do the remove one because I forget what it's called now, but it's a fast failure that if you're walking along a path and iterating over things, there are 5 things. Do the first one, second one, third one, fourth one, fifth one. If you're on the third one and you remove it, right, you're pulling the rug out from under yourself. So this remove method was always through an unsupported method exception. And unfortunately, that was so common, I think that they just got tired of always throwing this method, and so they introduced this idea of default methods so that they could always they wouldn't have to write that code every single time they did it. They failed to realize that it was a mistake to begin with to have all 3 of those methods, right? That was, in fact, we'll talk about the solid. That's a violation of the I in solid, the interface segregation principle, and so it was a bad design up front that they didn't like dealing with. They added yet another bad design on top of that in order to deal with it. So that's my personal opinion, and that's how I see it. I don't know that that's actually historically how they would see it, but I don't control Java. I'll write my own language instead. Yeah, there. Another problem is the Yoyo Anti-Pattern. So remember, anti-patterns are bad behaviors. So let me go ahead and go back to my notes here. Now, I'm drawing horizontally here, but you can imagine that, say that I've got a class, right? And then I've got another class, and I've got another class after that, another class, right? Another class, right? Dot, dot, dot. Another class, et cetera, right? I've got this huge, really, really deep hierarchy, right? And there's some superclasses up here and some subclasses down here. And you're somewhere in the midst of this hierarchy. Say that you're somewhere in the middle, right? And somewhere you always have to ask this question, am I being specific enough, or do I need to go down in the hierarchy? Let me go ahead and undo these. I should just have a laser pointer there. Say that I'm somewhere in the middle of the hierarchy. And I have to go down in the hierarchy in order to find something more specific. But once I'm down there, okay, I inherit this behavior. Where did I inherit this behavior from? I'm going to have to go all the way back up until I find what I'm looking for. In other words, I'm always going up and down this hierarchy over and over and over again, trying to understand what I'm doing, right? Kind of like a yo-yo, going up and down, right? And this is the yo-yo anti-pattern. If you're looking at this hierarchy and always bobbing your head up and down, looking and trying to make sense of it, you're doing something wrong, right? In other words, hierarchies generally should be shallow, right? Deep inheritance hierarchies can get very complicated. Complexity is not necessarily a good thing, right? They cause you to look up and down the hierarchy to make sense of the design, right? Don't do that. You're yo-yoing your head up and down all the time. Instead, keep your hierarchies shallow, or prefer composition to inheritance. Composition, there we go. Sorry, there we go. That's the correct spelling. So I put this in quotes because it is often quoted, but generally if you're trying to, you have a choice to make. Instead of extending a subclass, what you could do is you could make a wrapper class. A class that is a bigger concept that owns an instance of the class that you would have otherwise extended, right? So in other words, instead of a hierarchy looking like this, you can make it look like something like, here's A and here's B. Right. Oh, sorry, thank you. Here's A and here's B. What you could do instead is, instead of extending A, you could take and define B and then put A inside of it, right? Using composition. A would own an instance, or sorry, B would own an instance of A. And that doesn't lock you into a hierarchy at all. You basically have all the functionality of A by virtue of owning an instance of it, and all the methods, all the state, whatever else you're trying to do with A, you can totally make use of that in B, but it doesn't lock you into this rigid hierarchy up here. Right? And that's what we mean by using composition instead of inheritance. Okay. Another anti-pattern, or another problem that is often raised is the rectangle problem. So for that, I'm actually going to go to some code here. But before we do that, shape, square, and rectangle. What's the relationship between all those things? A square is a shape, right? Is a shape necessarily a square? Nope. But what about the square versus a rectangle? Is a rectangle a square? No. But is a square a rectangle? Yeah. From the perspective of grade school geometry. Let's find out what happens if we take that grade school idea into college level object-oriented programming or whatever, right? Not necessarily college level, but this is a violation of what's called the Liskov substitution principle. Here I've got a shape. Here I've got a square that extends a rectangle, and here, oh, I should have put it in the order over here. I'll put the rectangle over here. Rectangle extends shape, and then shape extends rectangle. The problem is, I'll go ahead and create a square, and at this point it's a 10 by 10 square. So it's a square. But then I set the height to 5. In other words, I change it into a rectangle. Now it's a 5 by 10 square. Is that a square anymore? Not semantically, but did its type change? It's still a square. Right? If I output this, it's going to output that it's like 50 units or for its, there we go. Oh, I guess not. S dot get area. There we go. Save that and run it 50 units instead of the 100 units. Right? But it's still a square, right? If S instance of square, then system.out.println, s is still a square, except that it is not. So, semantically, it's no longer a square because it's 10 by 5, but it is a square as far as the code is concerned, right? And this is a consequence of a bad hierarchy up front. And it leads to the rectangle problem. Sometimes it's called the ellipse problem because you've got a circle, an ellipse, and then a shape. Rectangle's easier for me. Ellipse is gross, right? I don't even remember how to define those. X squared, or x minus a squared plus y minus b squared is equal to 0? Or equal to r squared, or something like that. I forget. Yeah, go ahead.
Sorry, is it alright if we go back to the inheritance slide? I wanted to.
You mean this one, or?
Yeah. Oh, okay. Thank you.
All right, sure.
So how do you solve that problem, square?
Yeah, don't put it into a hierarchy, right? So if you've got, if you absolutely wanted to do this, I would do a shape and a rectangle, because sometimes a rectangle can be a square. Just don't define a square at all. Rectangle, ellipse, whatever other shapes you want, right? Or just polygon or something like that. In fact, another solution would be don't define these as a hierarchy at all. Just have one shape, and then that shape can be whatever you want, right? It could be, if you want a regular n-gon, then you just need a way to describe that shape. If it's just a series of points that define a concave, area or something like that, then a different representation. This is because it was from a flawed hierarchy. You shouldn't have locked yourself into that shape, rectangle, square kind of thing. Because semantically, a square may no longer be a square, right? Even though its variable type is still a square. So again, instead of locking yourself into that rigid hierarchy, rethink your design and make sure that you have a very well thought out design before you lock yourself into this hierarchy. Now for a project, it's not that big of a deal. You make 3 classes, this is wrong, throw it out. It's not that big of a deal to refactor. But if you have a hierarchy that looks like this, and then 25 years of code is built on that hierarchy, you're not changing it. You change it, all the dominoes fall. Right? Every piece of code out there breaks. Right? So you, with something that is super important, that is going to last and have lots of code built on top of it and towards it, it's got to be right the first time. Yeah.
Maybe that's why Java didn't change their code and
Yep, exactly. Java does not change code. Java's number one priority is backwards compatibility. They do not want, and in some sense, C has the same issue, where they're very, very conservative. You only have a new version of C coming out every 10 years historically. And even those have very, very little changes. Why? We don't like things breaking, right? It's not like, some cutting edge JavaScript framework that can just put out a backwards incompatible version every 6 months or something like that. And they don't care because everybody's rewriting web apps on a daily basis anyway. Angular and Angular 2 are not backwards compatible at all. PHP 5, 6, I forget which one, is not backwards compatible. 7 and 8, is it? Yeah. So basically, you're locked. That's why so many older versions, like our version of PHP on CSE is still 5. Why? Because upgrading to 7, 8 would break everything. Right? And so that's why we're still on 5 on CSE. But Java, yeah, you could take code that was written today and run it on a JVM. Well, no, sorry. You can take code that was written 25 years ago and still run it today. That was compiled 25 years ago and still run it today. You can't even do that for C. Something that was probably compiled 25 years ago would need to be recompiled today on different hardware. But Java Virtual Machine is virtually unchanged. As far as the basic core, it's backwards compatible.
The reason why they use
That it doesn't change a lot, yeah, and so if it works and you have some good guarantee that it's going to work 10 years from now, that's a very attractive choice versus some brand new language like Rust or something like that, where they're still developing the language. I'm not going to build $1 million system on that when it could all go changing next week, right? Money likes to be conservative, right? As far as polymorphism goes, I think I've mentioned it before, but you generally want to avoid operator overloading, even in a programming language that allows it. Java doesn't allow it at all, period. So you're good to go. You're never going to run into that choice. But something like C++, where, oh, I could overload the plus operator to do whatever I want, right? Rethink that. Prefer a well-named method that actually says what it does on the box, right? Rather than plus, what is that? Is that addition? Is that concatenation? Is it appending? Is it union? Right? Is it adding up two durations? Right? What does it mean in which context? I don't know if I remember saying this or not, but I don't remember if I said or gave a reference to PEX. This is more of a Java thing, Java-specific thing. But PEX is yet another acronym. It's just, you'll never have to memorize it or anything like that, but understand that it's out there. And it stands for Producer Extends Consumer Super. And it's a way of understanding what you were doing in Lab 5, right? So the two basic ideas is if you've got a collection that you hand off to a method, then that method is going to treat that collection in one of two ways, either as a producer or a consumer. A producer means that you are going to pull elements out of that collection and then do something with them, right? That collection is producing elements for you to work with. And if it's a producer, then that means that you want to use the extends keyword. Why? Because it provides a minimum amount of interface for you to work with. Instead of foo, it'll look much better if I use something like a checking account. Oops. There we go. If I'm going to sum up a bunch of balances, I need to know something about these things in this collection. I need to know that all of them are at least checking accounts or banking accounts or something like that, in order for me to call that get balance method. On the other hand, if you're not going to pull stuff out of the collection, then it's a consumer, right? A consumer, you just wish to put stuff in. Right? So it's going to consume. You have an element and you're going to put something in. Here's a use case. I've got a portfolio, a list of bank accounts, and then I've got this other bank account, and I want to know if I should add it to my portfolio. Only if it has more than $100. Otherwise, I don't care about it. It's chump change. Who cares about that, right? So only if it has more than $100 should I add it. Right? In that case, I would use the following syntax, right? Something like this. I would use the super keyword and a wildcard. Why? You don't care about what is in the collection already. Well, you only care that you can put a bar into it. Right? In other words, or in our context, a bank account into it. Right? Because you need to know that, well, this is the correct bag for what I'm trying to put into it. Right? And this the super keyword is what you would want there. You don't need a minimum amount of information because you already have it. Here's the thing that I have. I just need to know, can I put it into this bag? Is it compatible with the bag that I'm trying to put it in with? Right? And finally, Goldilocks everything, right? Be sure to make all of your parameterizations Goldilocks. Goldilocks. All right, who's Goldilocks? Goldilocks and the Three Bears? So the girl breaks into the bear's house. It's a kid's story. The girl breaks into the bear's house, and they've gone out for a walk, and she tries their porridge. The first porridge, the dad's porridge, this is too hot. So she ignores it. She goes to the mother's porridge. This porridge is too cold. So she ignores it. She goes to the baby's porridge. This porridge is just right. Right? So what does that mean with respect to parameterizations? Make it as general as you can, but not so general that it's just you lose all the information. You can treat everything as an object. but then you can't do anything with it other than put it into a collection and take it out and maybe print it or something like that. So you need you need to come down in your hierarchy and make it at least as much information as you can, or at least as much information as you need. Say, like a checking account. Oh, I went too far, because now I've got savings accounts that I want to deal with as well. So let's bring it back up. Not too hot, not too cold, just right. Right? So make it as general as possible, but not so general that you lose all information. And that's with parameterizations. Okay. This all culminates in what are called the solid principles. Solid is yet another acronym, and the solid principles are not object-oriented. They're an observation kind of. They're not rules. They're guidelines. They're guidelines for best practices when using object-oriented programming, because object-oriented programming was created in, you could say, in the 80s, and the solid principles were really only identified 20 years later. So they had 20 years of experience using object-oriented programming languages. They found what worked, what didn't, what led to problems, what stood the test of time. And these 5 principles were codified by Robert Martin and Michael Feathers in the early 2000s. S is for the single responsibility principle. Again, you should only have one responsibility in a class. Classes should not be God classes. The example that I said earlier was a person class should be responsible for person things. An address class should be responsible for address things. I don't think that we've seen any examples this semester, but a very, very basic error that people make is creating a person class with the first name, last name, street, city, state, zip. Right? That's screaming out to you. A person is not an address. A person has an address. Right? Therefore, we need to create another class because we have use beyond just the person class. The person has an address, but also a store has an address. If you did that first design where the person has the address, 5 elements of an address directly in it, then a store, you're going to have 5 elements over here in it. And you violated the DRY principle. Don't repeat yourself. Right? Take this repeated code and put it into a class, and now you can use that class in multiple places. Another anti-pattern that we did see, and that we always see, despite me telling everybody on Piazza don't do that, is that in the first phase, it sounded to me like you had 3 responsibilities. You had to load up data. You had to save it to XML. You had to save it to JSON. That sounds like 3 things to me. At a minimum, how many classes should you have? 3, right? Some people chose to use the data converter class to do one of these 3 things, or maybe these 2 over here. That was fine, but we wanted to see at least 3 classes if you were doing both of them, at least 2 classes if you only did one of those things. You could take that a step further. In fact, my solution does. My solution has 9 classes, actually more than that, because if you're going to persist to XML, you're persisting save to XML. You're persisting persons, stores, and items. Right? That was 3 classes for me. Right? Now, most people, of course, put those into one class, static classes. That's fine. That was an acceptable design. But I went, and it was acceptable design because we weren't grading on inheritance in the first phase. You don't have to change that design. Right? We're looking for inheritance in the second phase, but not necessarily on that stuff. Just some sort of inheritance. But if you want to go back and refactor it, you'll find that a lot of your code was actually repeated among those 3 different tasks. And you could have put that into a superclass and reused that over and over again. Right? Yeah?
How many variables should be there in the class?
Sorry, how many what?
How many variables minimum should be there in the class?
Oh, in which class?
Like if I'm making a class and I have just 2 variables that I can put in.
Oh, that's a good question. So is there a minimum or a maximum? Semantics dictate design. If you have an object and there's only one thing to that object, then yeah, so be it. If you had an example, we could pick that example apart and go back and forth on it. But generally, it would be weird to have a class with only one variable. Like what?
Like for names also.
Oh, name, so some people did do a name class, and that's going a little bit too far. Unless, of course, a name had a lot of stuff, like an honorific, a middle name, a last name, a first name, an alternative name, a preferred name, a suffix. Now you're getting into, okay, complexity needs to be managed here. Let's go ahead and put it into a class. At that point, I would say, yeah, let's go ahead and do something like that. But if it's just a first name and a last name, no, you don't need a class there. Yeah.
To avoid the rectangle problem, maybe this is a little too specific for the project, but like if it's like an item type, maybe you should make it so that the item type at least is final, if nothing else.
Okay, so
Things like prices, but
generally, and on Lab 5 and on this first phase, it was okay to have a type, like a string type, like S or subscription, or in Lab 5, I think it was the like temporary for employees and stuff like that. Generally, you don't want to do that though. Generally, you want to use the class as the type instead, right? And you don't want to say, you definitely don't want any code that says, oh, I've got an employee. How am I going to pay them? Am I going to pay them hourly, salaried, or something else, right? I'll rip it open, and what type are you, right? Well, I'm a temporary employee. Okay, well then I will give you an hourly wage, here you go. What's that doing? Functionality is outside the class, right? And that violates encapsulation. So generally you don't want to write code that depends on the type, like a string or something like that. You would put that code into the class and use inheritance to define that behavior. Right? But in general, for the single responsibility principle, classes should generally be small. Because larger classes means more responsibility and less reusability. Right? The O on the open-close is the open-close principle. And basically, the quote here, or the principle is that every unit that is a module or a class, or I changed this morning to be a module, comma, class, comma, method, should be open for extension and closed for modification. And that's just classical inheritance, meaning that you extend the behavior in subclasses, you leave the superclasses alone. Once you've defined your hierarchy, once you've put functionality up in the superclass, then that's it. Don't touch it. Why? Because any future class, or say that you build 50 subclasses based on this. And if you go mucking with something in the superclass, that affects all 50 of its children, right? Whereas if you don't put that in the superclass and make that a specialization, then you're not breaking anything if it changes. Right? So it's just basic classical inheritance. You can always change, it's open for extension. You can change it however you want in the subclass, but it is closed for modification in the superclass. And that just means getting a hierarchy correct the first time. It also means that if there's no default behavior, that's your signal to make it abstract, right? If you do know that there's this behavior that is common to all bank accounts, but you don't know how to do it, you don't put default behavior in the superclass, you make it abstract. And you force the subclasses to define how to do it. Have a good, well thought out inheritance because it's extremely difficult to change it later on. Imagine if Java tried to go back and change how this hierarchy here worked, right? It would break 25 years of Java code, right? And that ain't happening. The L in the solid principles stands for the Liskov substitution principle. And I found a video of Barbara Liskov herself giving a 5-minute presentation on it, and that's in the required viewing. And I really liked her very succinct explanation of it because basically violating this principle leads to that rectangle problem of the shape, rectangle, square, and don't do that, right? Basically, the statement is that if S is a subtype of T, then objects of type T may be replaced with objects of type S without altering any of the desired properties of T. In other words, an ostrich can always be treated as a bird, covariance. The opposite is not necessarily true. A bird cannot necessarily be treated as an ostrich, and a robin and an ostrich are completely incompatible, right? That's the Liskov substitution principle. Don't create a hierarchy that violates this, like the shape rectangle hierarchy. And I really liked her video because she gives some historic context to it. She said back when people were taught at UPSLA or at programming language conferences, she said that she never named names, but she said that she read this paper where they said that a stack and a queue were interchangeable. And that said, of course, that sends anybody who knows what they're talking about, that sends off huge red flags like, no, they're not, right? A queue is a line. You go in this end, it comes out this end. A stack is different. It goes in one end, and it also comes out the same end, right? It's LIFO, last in, first out, versus FIFO, first in, first out. And those are not compatible at all. And that's what drove her to be more rigorous about what this concept was. They defined several. They put out several papers, mathematically rigorously defining these things. And then she didn't name it the Liskov substitution principle. Nobody names stuff after themselves. At least if somebody names something after themselves, nobody else is going to use that name, right? Because it's pure vanity. Other people have to name the thing that you created after you. And that's when it catches on. So keep that in mind. If you ever invent something, don't name it after yourself. Let other people do it for you. Right? That's the Liskov substitution principle. Yeah?
So I'm having trouble understanding how you would do that in the square rectangle square example.
Because the square is a rectangle. Can I substitute... this one is kind of difficult. I can change a square so that it semantically is a rectangle, but I cannot change its variable type, right, at runtime. That it will always be a square. Even though now it's 5 by 10, it's not really a square anymore. Right?
So how would you do that so where it would not violate?
Don't put it into a hierarchy. Don't define it as an inheritance. Define it some other way. Yeah.
Can you put some rules, like override the parent constructor to make it?
There are some practical things that you could do. For example, like if you made it immutable, then you couldn't change its height to 5, and so at instantiation it would always be 10 by 10. Immutable objects, well, in a rigid hierarchy are fine, because they can't magically change they can't change their state, therefore they can't become something different semantically or typifically. They can't change their type no matter what, right? In a statically typed language. Now you throw all that out the window when you get into a language like, say, JavaScript, where JavaScript is an object-oriented programming language, but it's a prototypical programming language. What that means is that there are no classes. Instead, you have an object, and it's created ex nihilo. That's Latin meaning, do we know? From nothing, right? You just created it. Now, I want to make this into a duck. So what do? I take this quack method, and I put it into the class. Not the class, because we don't have classes, into the object. I take this, what else does a duck do? Waddles. And I put that, now it's a duck. How do you know it's a duck? Because it says quack and it's waddles. So we have an expression, if it looks like a duck, it talks like a duck, then it's a duck. That's actually called duck typing. That is a thing. So rubber duck debugging, people like ducks in programming for some reason. They just think they're neat. Duct tape. The I in solid principles is the interface segregation principle. And that just is a directive to keep interfaces small, right? You should keep interfaces as small as possible, i.e. 1 or 2 or 0 methods each, right? Because no client code should depend on methods that it doesn't use. here's an example of a violation of this principle. Suppose that I have a click event handler interface, right, that looks something like this. Right? In other words, I want to define what happens. Here I've got a button. I want to define what happens when it gets clicked. Right? What if, suppose this interface defined both of these methods, on click and on double click. Right? That's the other thing that you can do. It's the click event handler. If I implemented this interface, I would have to implement two things instead of just the one thing I wanted to do. You click this button, it saves the file. You double click this button, I don't care. I don't want to define that. But by making this interface large, two methods, it forces me to decide, well, what happens with a double click? Well, it saves it, or it saves it twice. Or typically what people do is, if you're forced to implement a method that you don't care about, then you either throw an exception, an unsupported method exception, or you simply just have the double click method call the on click method, so that it has the same effect. Right? Double click, click, it saves it. Right? It doesn't save it twice. But the problem is that you've made this interface large, and I'm forced to deal with everything that you gave me. You'll see this again later on in the final phase of your project, where you have to implement a sorted list class. Some people are, well, if it's a list, then I should implement the list interface. Good luck. You've got about 24 methods that you don't care about to implement. So don't do that. Right? Interfaces should be kept as small as possible. They should be segregated from each other. That the click and the on-click should be in separate interfaces. You can implement both of those interfaces if you really want, or one, or the other, or neither. Right? It's your choice now. It's way more flexible. Right? Basically, this design it forces you to implement both events, right, when you really only care about one. And the final one is the dependency inversion principle. And I've always struggled to come up with a good example because we cover this before databases. So here's the idea. High-level modules, classes, should not depend on low-level modules. Or high-level should not depend on low-level. And for that, I'm going to go ahead and create and draw something new here, or draw something else here. Here we go. So I hate the name of dependency inversion because to me, when you invert something, it sounds like you're flipping it upside down, right? That you've got a high-level module up here and a low-level module down here, and you've got a dependency that looks like this. The high level depends on the low level. Inversion to me would mean that you take it and the low level module then is flipped and the high level module is down here, and then you still have a depends on. Right? That's probably the visualization that you had too, right? Wrong. That's not what it means. It means something like this. You have a high level module up here that depends on the low level module down here. What you do is that should be called decoupling instead of inversion. What you do is you take away that dependency. Here's the formerly high level module, right? And here's the formerly low level module. And you note here that I put them on the same plane, right? They no longer depend on each other at all. Instead, they depend on something in the middle. Right? Both of them depend on something in the middle. That something in the middle is called an interface, right? That we've been talking about. Right? That this defines an API, an application programmer interface. Or sometimes if you're low-level stuff, an ABI. Does anybody know what that is? Application binary interface. You've already compiled, how should your binaries interact with each other, right? It's much lower level systems kind of stuff, but it's the same idea. It's an abstraction. You don't have to write your code over here in the high level abstraction to depend on something low level anymore. You write it towards an API. And anybody that writes a low level interaction, they also write towards the API. and there's this complete independence. People over here can work independently of the people over here, and they never have to meet except for the common interface between them. Yeah?
Would having 5 be an example of what's going on the left?
No, that's pure inheritance. What we mean by dependence here is a little bit different. And here's the example that I'll use since we haven't gotten to databases yet. But a database API is a perfect example. And here's the short of it, what we're going to get into, where I could write code to connect to a MySQL database. Right? 5,000 lines of code invested. And it connects to a MySQL database. It has nothing to do with my business rules for producing sales reports. Right? It just puts stuff in and takes stuff out of the database. 5,000 lines. Now I want to change it so that it's not MySQL anymore. I want to move over to Postgres because it's free. Take that 5,000 lines of code and throw it out because you wrote it for MySQL only. Rewrite it all for Postgres. Okay, oh, wow, our business has grown. We can no longer use Postgres. We bought a SQL Server package from Microsoft. Take that 5,000 lines of code, throw it out, and rewrite the 5,000 lines of code for Microsoft's database. Right? The low-level dependencies are your databases. MySQL, Postgres, SQL Server. The high-level dependencies are your business code. And the thing in the middle, so you wrote 5,000 lines up here. What you should have done is should have wrote 5,000 lines of code to something in between, an application programmer interface. So that changing a database, you don't change any of your code up here. Instead, you take and rip out the driver and put in a new driver. Nothing up here changes because it depends on this abstraction in between. Here's an example that maybe is relatable. I don't know. Say that I am doing some Android development or something like that. I'm doing some mobile development. And I've got library A that gives me a GPS location. And it's got it's just static methods that return a double, negative 180 to positive 180, negative 90 to positive 90, so degrees. And I can call these two methods and get my latitude, longitude location. I also have the option of using library B, which is Androids. And this is not real, by the way. This is not how you do it in Android. But you've got Android native, and it returns this Android location. Once you've got that location, then you can call these methods get latitude and get longitude. Right? So slightly different. Library C pulls everything directly off of triangulation from a cell phone tower or something like that. And instead of negative 180 to positive 180, 90 to 90, it does it in radians. Right? So 3 completely different ways of getting the same information. If I were to write high-level client code that depends on these 3 low-level modules, it would look something like this. A bunch of if-else-if conditions. If library A, then call those 2 methods, wrap it up into my location, right? If library B, then get the Android native location, get the latitude and longitude, and wrap that up into my location. If library C, then convert the radians into degrees, wrap it up into a location, and send that on. Right? Maybe a library changes, and these methods get deprecated. And so what am I going to have to do? Another if-else-if statement. Else if, else if, else if, else if. Right? I'm making all of these complicated decisions. Whereas, what I could have done instead is I could define one interface. That interface would look something like this. Right? You can define one interface that returns, call it locator interface or something like that, that returns a location from a get location method. Right? Then you can implement 3 wrapper classes, each one for each one of those libraries. Right? And it wraps up each of the logic up here instead of in a big giant if-else-if statement. Now I've got separate classes. And you want to use this library? Okay, go ahead and instantiate an instance of that library or of that wrapper class and use that library. If you want to use this other library over here, then do that, right? You don't have to check for this if-else-if all the time. And then go in and change your client code to suit any new library that might come along. Instead, you write one piece of code towards your API that never changes, And now if you've got a new library that comes in, that's a new class, and it implements that interface instead. You've taken out the dependency entirely, and it all depends on this thing in the middle, this abstraction. All right? Questions on the solid principles? And again, there's also another acronym. I forgot what it was. Let's see. Solid versus something principles. And we've got terrible internet today, so it's not working, and it's not pulling anything up still. Okay, no, never mind. I'm going to have to be way more specific because I'm getting solid versus engineered wood. Solid principles versus, and then I'm just coming up with design patterns. There was a 4-letter acronym that basically was a reimagining of these that came along like 10, 15 years after that. So here's some more principles, and we need as with all acronyms, you always try to shoehorn them in. And so maybe that's, no, it should have been dependency decoupling principle. So DDP or something like that instead of DIP. They could have still used the D there. I don't know why they thought of inversion. Inversion to me always means you turn it upside down, and that's not what it's doing at all. It is taking and decoupling them entirely. Yeah. Okay. So any questions on OOP? Yeah.
So, I just have a question whether it's good or bad practice. So, for example, I have a list of something that I define as like a superclass type, and it contains subclasses of that superclass. And then, at some point, I want to work with that list and get out like certain subclasses, and one subclass has like its own different functions that are not in other subclasses.
Right. So you do have to do a contravariance there. If you want to treat a bird, you have a bunch of birds, and you want to treat it like an ostrich because it has methods that a robin doesn't have.
Yeah.
Right. So think about refactoring it so that, well, why doesn't this thing over here have that method? If it doesn't, if it truly doesn't, then yeah, you're going to have to deal with these differently. But is there an abstraction that you can make that's common to all of them, right? And you might be asking that because on your project, right? Your project, the way that you compute the price of an element is different, and it depends on what the element is. But that tells me that the subclass should have a get price or something like that, right? And then for a used copy of Zelda, it's only 80% as much as the base price. And for a new copy, it's the full price. And that logic can be handled inside each of those classes. Now, the one exception to that is your copy constructors, right? So I've got a flock of birds, and I want to take this and create a deep copy so that I've got the exact copy of birds over here. If I just take a bird out, I can't call the bird constructor because it might be an ostrich, it might be a bird, it might be a robin. I need to know, is this a robin or is this an ostrich in order to call its copy constructor? In that instance, that is one of the few instances in which I would say, yes, you can use some sort of mechanism to say, is it a bird, is it an ostrich, or is it then call the ostrich constructor? Is it a robin? If so, call the robin constructor. Because you have to. There's just no other way. Now you can use the instance in Java specifically. You can use the instance of keyword, or you can go back to what John was suggesting, and we have a get type method, right? That tells you what type it is.
Yeah.
That either one of those is acceptable, but only in that instance where you're creating copies because you need to call that copy constructor.
Yeah, because like why I was asking because, for example, I have a person class, and a person can be either a customer or an employee, and employee has entities that are not for a customer, like sales and stuff.
Right.
And if I want to use statistics for like a sales person, then I would have to.
There's no problem. So with something like that, you could maintain a list of customers and a list of employees. Or you could maintain a list of people and separately a list of employees,
Oh, yeah.
right?
Yeah.
And that would be a little bit better than just separating them completely, right?
Yeah.
And then you would have your statistics on all the employees that you need.
Yeah.
That would be a better solution than going through and, are you an employee? No. Are you an
Yeah.
employee? No. Are you an employee? Yes. Run my statistics, right? It'd be much better to just maintain that list of employees if you're going to use the inheritance there. That might also cause you to rethink, do I really need this inheritance, right? Is there another way? And I'm not saying that it's a bad inheritance. It's just that there are obviously bad designs. 10% of all designs are obviously bad. They're obviously good designs, right? The 80% in the middle, you can have a healthy debate about. Right? Yeah.
So you're saying you expect an inheritance, like you expect to see some kinds of inheritance.
Yeah, and correct inheritance
Yeah, incorrect inheritance
in your next phase.
in our next phase, but we also need to be really, really careful in how we do so, lest we have to bend over ourselves.
Exactly.
Like for the
Don't paint yourself into a corner when it comes to the rest of the project phases. Right? And questions like that are exactly what comes up.
Is there
Right?
any like general guidelines you would use as to whether use inheritance, like this should be a subclass versus this should not be a subclass?
I mean, the one example that I gave earlier today in the main section was, take a look at their inheritance over here. They've basically got a repeated inheritance hierarchy for set, collection, and list. That's repeated again here, right? They chose to make it like this because it's like a mirrored inheritance. You could do something like that with, say, your items. I've got items. You've got subscriptions and products. I'll just simplify it to those two, right? So you've got products and you've got subscriptions. Those ideas exist independent of whether or not they're on a sale. What you could do is lots of ways that you could do this, but one way that you could do this is by making a mirrored inheritance below that, where now this is a subscription on a sale. This is a product on a sale. You inherit everything and then you add to it. You also have the number of Wiis that you just bought, or not Wiis anymore, number of Switches that you bought, or the number of copies of Zelda that you got. Over here, subscription, it runs from the 1st to the 31st, right? That's the extension in your subclasses. So you could have an inheritance hierarchy and it's entirely repeated down here. Or you could have your hierarchy that you have before, and then you inherit each class. Instead of the full hierarchy being a copy down here, you just inherit off of each one and then it appears on a sale. Or you could prefer composition over inheritance. Or you could just go with that one hierarchy by itself and then use copy constructors to put it on a sale. Right? All 4 of those are completely fine designs. And I've described them abstractly enough that if you understand the material, you'd be able to do any one of those 4. You just need to decide, how am I going to do this, right? When you're looking at a design A and a design B, it's not a matter of this is a bad design, this is a good design. This has advantages and disadvantages. This has different advantages and disadvantages. And then you have to weigh them, right? The advantages outweigh the disadvantages over here, but the lack of disadvantages outweigh them over here. Okay, we'll go with this. Right? Until later on when we found out, oh wait, there's a disadvantage that we didn't think of over here, and we should have done that. In which case you just go back and you refactor. It's not that big of a deal. All right? Yeah.
I have a question now.
Okay.
So for my items, I would have get price, which get the base price, and then get quantity, which get the sale quantity. But for subscription, it has the price for 1 year, and then the quantity would be a number of days.
Okay.
But then when I multiply them, I need to divide by 360, so I need to use a if statement.
Well, the quantity could be 365. The quantity could be the fraction of a year.
Oh, that be Okay.
right? Or I mean, quantity tells me that that maybe just apply to products, right? That what you want, that's not the correct abstract. The correct abstraction is get sale price, right? And now the logic for getting the date divided by 360 times the subscription rate, that's all handled in one location, right? Quantity is something that only exists as far as products are concerned, because you can buy 3 switches, or you have to buy 2. Does anybody own a Switch? All right, how many switches do you have? Exactly. Nobody ever has one switch. Why do we all have 2 switches or more? Oh, okay. Because it's garbage hardware that craps out. I've replaced the controllers 3 times. I've repaired each one of the controllers once. I replaced the fan once. If the fan goes out, the entire thing goes out, because it's the battery goes from the battery to the fan to the actual circuit board. So if your fan goes out, it has to be replaced entirely. It doesn't work anymore at all because the battery is not connected anymore. And oh wow, it's cheap. It's some cheap damn hardware.
Maybe it's a good design, so
Yep, it's called designed obsolescence. We need you to buy another Switch next year to recoup our money.
Well, my problem with it was I could use my account with the second one because, like, I was the one who owns it.
Yeah, the Nintendo Online stuff is terrible too.
But the rest of the people in my family can't use it.
Exactly.
So it's just like, well, that was.
Well, we'll take this offline, but